We've spent the last few videos focusing specifically on arcsine, and we know y equals arcsine x when we switch the x and y in sign, and that makes our domain switch to -1 to 1, and our range switches from -π/2 to π/2. There are similar rules for arc cosine and arc tangent. So arc cosine connects to the graph of cosine. We know that cosine has a period of 2 pi, and we can split that up into these 4 intervals, and we know it has a max of 1 and a min of -1. So if I sketch cosine x, it looks like this curve here. Cosine x. That's one period of it. However, if we draw a horizontal line, this does not pass the horizontal line test. So therefore, it doesn't have an inverse on this period. So we look at what piece of that period does pass the horizontal line test. And we can see from here to here, 0 to pi, it passes HLT when our x values are between 0 and pi. So therefore, when we are looking for arc cosine, we notice that our y values go from 0 to pi because it switches with our x's, and our domain is from -1 to 1 because it switches with our y's. So graphically, we know we can only find arc cosine between 0 and pi. Arc tangent, we know that connects to tangent. Now we know tangent has vertical asymptotes at -π/2 and π/2. And tangent starts down and goes up through this 0. So this is tangent x. Now if we focus just on this period, it does pass the horizontal line test on this period. So therefore, the range for arc tangent is -π/2 to π/2 because we switch our x's, and the domain goes from -infinity to infinity because we switch our y's. So we summarize here, y equals arc cosine x. If cosine y equals x, its domain or possible x values are -1 to 1, and its range or possible output values are 0 to pi. Y equals arc tan x. If tan y equals x, its domain is from -infinity to infinity, and the range is -π/2 to π/2, not including those values because those were initially vertical asymptotes. So now let's get into some more examples in the next videos that include all 3 types of inverse trig.